Okay, the key to this problem, and I gave it to you out of context earlier, specific for a reason, and the idea is when you're working through a quiz, it's not necessarily going to be under this title of right triangles. Okay, so you might not figure that out right away. So as you draw your circle, a lot of you would likely set it up A, B, C here, and then diameter of 10, and then when you go to look at these arcs, okay, if you have a ratio of arcs of 5 to 3 to 2, how many total parts are there in that ratio? 10, right? So this is 5 out of 10, 3 out of 10, 2 out of 10. Well, when you look at the 5 out of 10, the AB, that represents what fraction of the whole circle's rotation, or the 1/2 of it, right? So what that means is AB is a diameter. And so you might need to just figure it out through the context of the problem, that here's AB, right? And then that means C is going to be somewhere up here. Okay? And so when you look at that, if you look at each of those ratios, bless you, 5/10 of, 3/10 of, and 2/10 of. Okay? The full rotation of the circle, 360, this is going to give you your corresponding arc measures. And so when you look at this, 5/10 is half, so this is an arc measure of 180 degrees here. 3/10, you get 3 times 36, so 108 is BC. And then that leaves the 10 powers of 10 cancel, or factors of 10 cancel, you get 72. And so these are your arc measures along the circle. And so you can identify, bless you, your corresponding angle measures. Anytime you inscribe an angle in a semicircle, it's going to be 90 degrees. You can also look at it as intercepting this arc of 180. It's going to be half of that, or 90. And then B is going to be half of 72, so that's 36. And then A is going to be half of 108, so that's 54. You are also told here, since AB is a diameter, that it is a length of 10. So once you get to this step, you now have your right triangle. And so if you know that your area is going to be calculated with a base and a height, those are the legs of your triangle. What we can do is we can identify those using trig ratios. Okay? So when we look at this, since we have an angle measure, I'm going to use this 36 right here. With respect to this angle of 36, my base is opposite, my hypotenuse is known. So opposite and hypotenuse are related by which trig ratio? Sine. So I know that the sine of 36 degrees is going to equal the opposite B over my hypotenuse 10. So if I multiply both sides by 10, I get my base alone. Okay? I then need to know my height. So to calculate my height, I can either use the same angle if I want to. With respect to angle 36, height is adjacent and hypotenuse. So I can use the cosine for that. But if I wanted to, I could also switch angles. With respect to this angle A, 54, the height is opposite, 10 is the hypotenuse. So again, it's still a sine ratio. So I could have also said that the sine of 54 degrees is equal to height h over hypotenuse 10. Multiply both sides by 10. So I get my base and my height. And so my final step then is to calculate my area, 1/2 base times height, where here's my base, here's my height. And I can do that calculation here with my calculator. Okay, so if I take 1/2 times my base, which is 10 times the sine of 36, I already have a decimal, so I don't need to put a decimal there, times my height, which is 10 times, I use sine again of 54 this time. And when I hit enter, I get my final solution, which is 23.78 approximately. The units aren't provided, so I'll just use generic U squared unspecified units for my answer.